Hello, everyone. Welcome to this week's irrigation scheduling update for row crops. I am Bram, a research assistant at the Otis Precision Ag Lab here at the Auburn University. And today we will continue to dive deep into the latest insight from our fields and how these influence our irrigation recommendations. Efficient irrigation isn't just about supplying water to the crops, but has got to do with the timing and precision, knowing when, where, and then how much water the crop needs, and also adapting to real world situations. And that is why we are committed to providing data driven recommendations to optimize irrigation and ensure efficient water use and also optimize crop yield. So in this series, we will have a look at data from our irrigation scheduling tools and also analyze the weather pattern and then discuss how these data influence our irrigation recommendations on these fields. So it's been 10 weeks since we planted and our corn is already in the period of peak water demand. And during this period, we it's very crucial and we want to make sure that the plants are supplied with adequate water and in order to prevent issues with plants or crop stress, which in the end impact our final yield. And then the weather data during this period has been a very important factor. And from our Davis weather station we have installed on site, we recorded high temperatures between 83 to 92 degrees Fahrenheit and nighttime low temperatures between 59 to 71 degrees Fahrenheit. Also, several rainfall events were recorded, where we recorded about 0.82 inches on the 29th of May, 0.62 inches on the 6th, and then 1.8 inches of rain on the 8th of June. And for a farmer may say he is relieved of irrigation during this period, but it's very important to uh, look at the soil moisture conditions. And the rainfall it's not just about the amount of rainfall that is coming in, but also the distribution of the rainfall is very important. That is why we find the need to have a critical look at the soil moisture in of the field. So this is data from our irrigation scheduling tools during the reporting period. And on the 29th, the farm received 0.8 inches of rainfall, leading to a complete refill of the top 48 inches. And this means that the deeper soil layers were fully recharged, eliminating any immediate need for irrigation. But as the soil moisture began to decline, the aquaspire showed a drop to about 37.8 percent, signaling the need for irrigation in order to prevent the stress. So to prevent further decline, we added 0.4 inches of irrigation, and this timely irrigation helped to replenish the soil moisture, keeping the crop in optimal condition. And then additional rainfall on the 6th of June, we received after we applied a 0.37 inches of irrigation, we received additional 0.62 inches of rain from which provided us further relief. So this naturally restored the soil moisture levels because this rain replenished the available water and no additional irrigation was needed at that point. So the soil moisture further went down to 59.6%. But then on the 8th, we received a significant rainfall of 1.8 inches, pushing the soil moisture to 97.8% at the deeper layers or the top 48 inches. And this ensured that water availability remained across the root zone and sustain plant growth without the need for any extra irrigation. If we look at the data from the CropFit app, we can see that from June 1st to June 3rd, the soil moisture deficit gradually increased, reaching about 14%, which uh, gave us a value of 0.4 inches to refill in order to ensure optimal moisture conditions. And after the irrigation, the deficit dropped to 3%, showing that the crop responded well to the replenished soil moisture. Then came a rainfall on the 6th of June, and this naturally refilling the soil moisture reduced the need for the irrigation need. So by June 8th, we received a very heavy rainfall, which had fully restored the soil moisture, leaving us with a 0% deficit up to the term. So the CropX ET sensors also gave us readings on the crop evapotranspiration, and we can see that the ET peaked at 0.3 inches on the 3rd of June, and just before irrigation, and this shows high water use as we discussed earlier, meaning replenishment was necessary. But then after the rainfall on the 6th of June, the ET dropped significantly to about 0.06 inches. And this was because the soil moisture was high and then plant transpiration was less. But then as the temperature rose post the rainfall, the ET gradually increased again, highlighting the importance of monitoring of the soil moisture levels before applying any form of irrigation. So during this week, we can say irrigation was timed strategically and applied when the soil moisture deficit was increasing. And then also the rainfall that key events also played a major role in replenishing the soil moisture, reducing irrigation needs for several days. So monitoring the ET ensured that we also match the irrigation to the actual crop water use, which helps us to prevent over or under irrigation. So this is a graph from our CropX ET, and this gives us value on the crop ET. But then the crop ET is influenced by several factors like the temperature, the relative humidity, and then our water input, which could be irrigation or rainfall. So leading up to the 3rd of June, the soil moisture levels declined steadily, and then the ET was also increasing. And during this period, our ET peaked at 0.3 inches uh, per day. And then this rise indicates that the crop was actively using water and then also pulling water from the deeper soil layers due to the depletion in the upper profile. And at this stage, it was very important for us uh, to apply irrigation to avoid any stress. So on June 3rd, we we applied 0.4 inches of irrigation, and this immediately affected the soil moisture levels. And following the irrigation events, we saw that our crop ET dropped, indicating that the crop had sufficient moisture access and reduced need for to extract water aggressively. And this confirms that the irrigation was well timed to prevent excessive transpiration caused by the declining in the soil moisture levels. So between the 6th and then the 8th, a significance of rainfall events, occurred, and then we even had we applied is also applied 0.3 uh, inches of rain of irrigation during that day, and we received 0.62 inches of rainfall, and then 1.82 inches of rainfall as well. And then after this event, we can see that our ET sharply declined, reaching some of the lowest values during the period. And this is because when the soil moisture is replenished from rainfall, the plant reduces transpiration since water is available and there is no immediate need for the plant to extract water from the deep layers. But additionally, when there is a rainfall event, after a rainfall event, usually our uh, relative humidity increases, and this further reduces the ET by lowering the vapor pressure deficit, which is the difference between the leaf water vapor and then the atmospheric moisture. So, following the several days of sufficient moisture, our our ET began to rise on on the 9th of June and then the 10th, reaching about 0.25 inches per day. And as the soil moisture is depleted, the plant resumes the normal transpiration rates in order to extract water, which causes the ET values to increase. And this signals that irrigation should be reassessed or revisited depending on the soil moisture reading. So from this graph, we can see that the as the ET increases, the soil moisture also declines. So as the soil moisture declines, the AT increases as the plant extracts more water. And then we also see that the irrigation event also irrigation and then the rainfall also provided accessible moisture leading to low ET values, and also the relative humidity also suppresses water loss due to the lower evaporative demand. So the ET rises once again once the soil begins to dry, signaling that the irrigation may need to resume, or we may need to revisit and apply the irrigation.